last little section.
Wait, ever?
Well, yeah, actually, guys, this is the last lesson.
Really?
No, seriously, this is it. Yeah. No.
Oh, no, back in junior, baby.
All right, listen though, this is actually, I mean, I think this is a big possibility for you guys to get as your 6-point question though, because I haven't done it in a little while, and this would be pretty tough. So I need you guys to like kind of really focus and have a reference sheet out. All right. I also have a reference sheet up here. I'll kind of help you with. The steps are very, very similar to what you guys have been doing, but again, the solving process is just what's going to change. So one thing that's going to come up today is you're not going to, you know how we've had all cosines, all sines, all tangents and everything. Today, we're going to have different things, like mixed angles or things that are in there, mixed different trig functions. So what's going to happen and be really, really important is to have Pythagorean identity. Does anybody remember the most important one? Plus sine squared equals 1, right? Or sine squared plus cosine squared equals 1. Doesn't have the order. Right? That one is going to come up. It's super, super important for what we're going to be doing today. Now, when you guys look at these, solving these equations, all right, for theta, what you want to look and see is, do you have all the same trig function, or are they mixed? Here they're mixed, okay. Your goal is, if we can, we want to find a way to get one trig function. So we want to find a way to get all sines or all cosines. Right? Some things that are the ways we're going to be able to do that is, one way is to use the Pythagorean identity, maybe something up here as a substitution. You may also have double angles that show up, where we have to use that formula sheet, like from last chapter, right? If there's no way that you guys can get one trig function, you probably have to factor out a GCF, right? So these are kind of all the different methods that you guys are going to see. So let's look, once you guys realize that you have two different things going on, look to see, do you have any double angles?
Yeah, we do.
Remember the double angle, the 2 has to be in front of like just the theta part. It has to look like this, like a big 2. No. Okay, so we have no double angles. Alright, so we're kind of stuck. Like the only way when you guys have these mixed trig functions to get them into all one thing is to use your Pythagorean identity, right? Is to use this thing, right? When you guys learn ways to kind of solve this, does anybody know what cosine squared was equal to? Close. 1 minus sine squared. Cosine squared was the same thing minus, oh gosh, I'm running out of room. Cosine squared was really equal to 1 minus sine squared, right? So what we're going to be doing is making a substitution, right? We're going to get rid of that cosine squared, but put in 1 minus sine squared in its spot, right? So it's like a replacing, a substitution. Right? Everything else is going to stay the same. Yeah.
Can you do it the other way if you wanted it? Like if you substitute the sine?
If it was like, let's say it was the other way around, like if you had a sine squared and a cosine here.
Oh, right.
Yeah, you could do that. You can't really the other way because this is it squared.
Okay.
That has to be squared. So now this looks like what you guys have been dealing with, right? We have all one trig function. It gets easier once you guys have the one trig function to make these into x's.
So should we move everything?
Yeah, we're going to do a lot of moving here.
Just move all left and right.
Yeah, Carly, why would you want to move actually the left side?
Because that's good.
Perfect. Yeah, we don't want this negative x squared. So bring everything across. We're going to add x squared minus 2x minus 1. And then let's see what we got. So make sure it's in standard form. The x squared should be first. And then we have a minus 2x. What's going to happen with the 1? Yeah, those are going to go away. All right, so this is it. GCF. Love it. Great job. Okay, perfect. So plot an x, so we have an x minus 2 equals 0. Flip the page. Okay. So at the end, when you guys set everything looking here, we have x equals 0 and x equals 2. Just make sure. What did you make them all into? Sines. Good. So this is really sine x equals 0 and sine x equals 2. Right? Your goal was to figure out what x is, and it has to be, 0 to 2 pi. Oh gosh, what does that mean? You have to make this radians base plus you. Okay, so well, the second sine is 0 and figure out what that is. 0. That's 0. Okay. Good, and get 0, right? Alright. Now remember when I told you guys if you get something with like 0, 1s, or negative 1s, what do you want to draw? The chart, yeah, because remember, it doesn't give you everything, right? So here's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, we were looking here, the sine was 0. So if we look at all the signs, right, you guys got from the calculator that this was 0 degrees. But what is this also the same thing as? 360. Good job. Okay. Anywhere else at the sign 0? Maybe. Super. Okay. Now, if we want to turn these into radians, because that's what it asks us in for, it gives your interval in radian form. Anybody? Well, 0 is just still 0. Yeah, you should try to know these though. What is 180 the same thing as? Hi, thanks, Andrew. Good job. What's 360 then? Think about 2 pi. Good job. Right, now, if you didn't know that, you guys would have to take your like 180 and multiply by pi over 180. 180 just cancel that by just pi.
Oh.
You know, so you can do the whole conversion if you want, but you really don't have to. Right, what about this part? What's going to happen here? Yeah, it's an error. Good job. That's not going to work. So we have 3 options here. Now, if you were just relying on your calculator, you would have missed the other 2, right? You only had that one. So just be careful you're drawing things out. Right, there's another one. The hardest part is starting it. Everything else at the end is the same. You guys have been doing it since like Monday. Oh, good. All right, perfect. I love that you guys were recognizing that right at the bat. Okay, so here, bad things. Double angle, we cannot have it. So let's look at our reference sheet. Okay, so here's our double angle. Here we go. Love this little thing. Okay, let's see. What else do we know about in the problem? We have sine, right? This is already here. So when you guys pick the one you want only sines in it. So let's see. Which one do you guys think had only sines? The third one. Yeah, we're going to choose this one right here. Good job. Okay, so it's going to be kind of the same substitution. We're going to get rid of that double angle, and we're going to put 1 minus sine squared in its spot. So we're going to get rid of this. We're going to put 1 minus this. 2 sine squared thing. 2 sine squared in its spot. Everything else is just going to stay the same. So then you have plus 3 sine theta. Do we have a one-trig function? Yeah. Great. So if you want to, at this point, we can make them x's if you'd like. Rather that. Yeah, good job, Frida. Okay, I would not want to factor something like this. Kind of pain in the butt. So move everything over. If you are going to move everything over, what's just going to happen with all the signs? They're just going to change. So if you want to just say, okay, this is going to be a positive 2x squared, this will be a minus 3x, and then a minus 1. All right. How do we want to find x? Back. Okay, all right, well, we can try quadratic, we can try grouping method. You can also do guess and check. This would be a very easy one to guess and check if you were a guess and check person. Because how many options do you have for 1? 1 and 1. What are your options for 2? 1 and 2. So, if you are a guess and check, does anybody in here do guess and check? Some of you? This is easy to guess and check. Would you guys, most of you guys, do a guess and check or grouping? You would never do guess and check? You don't do grouping? That's fine. I hate grouping. It takes so long. So let's do a guess and check. This is great. We'll do a little bit of practice. Okay. Have you already started grouping?
No, but I think
oh, okay. So Yeah. Anytime you're going to find that. Yep. Unless you physically can't factor it, then you only can use the quadratic formula, which happens sometimes. Like yesterday, I think it happened. Alright, so let's see. Do we have things that multiply with b2? Hopefully 1 and 2. Those are the only options. X squared is just x and x. And what are your only factors of 1? 1 and 1, right? Okay. So we want to get a minus, here, we can't do it. Okay. Yeah, I can't. Alright. So if this is good, Allison, because we're going to try to factor and we get stuck. Okay. Now your only options here, to get a negative 3, what would your sign have to be? Both negative, but cannot make a, no, oh goodness. Yeah, we get stuck. Because if you tried, this would have to be a positive. Alright, so we can't factor. What do we have to, what's our only way that's going to work? Oh gosh, we have to use the quadratic formula. What is this? Okay. So, let's see, we have 3 plus or minus the square root of 4, 3, all over 2 times a is going to give us 4. So let's check out what these are going to be for. We might not be able to finish today. Or tomorrow. Sorry. Eliza. Negative 3 squared minus 4. No. 3 squared minus 4 times 2 times negative 1. You get a 17. There you go. That was that. You did. Thanks for your help. Okay. Alright, so with this, we have 3 plus or minus radical 17 over 4. This would be a great 6-point question. This is hard. Okay, now remember what your goal is. Kind of like the one we went over. Can we figure this out the way it is? Split them. Yeah, let's split them and figure out what they are in decimals because it'll be much easier to work with. So we need to figure out what 3 plus radical 17 is over 4. And then what 3 minus radical 17 is all over 4. 3 plus radical 17. Make sure you guys are doing the top and then the bottom. You get like 1.7807.
Yeah.
Okay. Right, remember this is not your answer. So we don't want to round this too much. So let's do like 1.781. 1.781. Alright, let's see what the other one's going to be. Okay, go ahead and do the minus one. Yeah, negative 0.238. Let's do 8. We'll round it up. We'll go back there. How are you guys with entering these? Are these getting better to enter? Yeah. Okay. So once you're here, now we can actually figure out what this value of x is. So we want to use your second function key here. So second sign 1.78.
I got an error.
Oh, good, yeah. You should get an error because it's over 1, isn't it?
Yeah.
Even though it's a decimal? Okay, so yeah, that one doesn't even work. I love when that happens. Alright, so let's try this next one. Oh yeah, we're such a pain. Negative 0.2808, is that it? Okay, so negative, what do they want us to round here to? Nearest, oh, nearest 10 too. So negative 16.3. Negative 16.3, sorry. Okay. Right, so is sign here positive or negative? Good. Okay, so let's think about what quadrant we need to get into. Sign is going to be negative in the C and the C. This has been kind of confusing, you guys. You don't want to use negative 16.3. How do we figure out what that's equal to? From 360. Good. So take your 360. You're going to go down because a negative degree measure means you're going down that much. Right? So we're going to subtract 16.3 from 360. Frida, what'd you get?
343.7.
Awesome. Great. Okay, so this one's fine. Now we have to get into the T quadrant. This is another thing that's kind of confusing you guys. What are you going to add to 180 though? Good. You want to add the reference angle. Missed that. The 16.3. Good work. What would that give you guys?
196.3.
So those are the two answers. Can I leave them in degree form here? Yeah. And just make sure they both fit in the interval that you're given. Right, 0 to 360. Sorry, go ahead.
They're asking those two quadrants because those are the negative quadrants.
Right, because sine was negative. Yep. And this one didn't even work, so we were done there. Okay, let's try another one. Oh, good. This is the one I really wanted to get to.
We can skip on.
We can start it. Okay, so let's look to see. What do you guys think? Okay, good. Double angle, super bad. We need to get rid of it. This is not okay.
There's only one option.
No. It's so good.
But it's still not going to give you all the
Right, you only want one trig function, but what you guys are saying is fantastic. Right, if you look at the sine double angle, we only have one option, which is this thing. It's not 2 sine x cos x. So at least, all right, well, 2 sine x cos x. Oh wait, I forgot a plus sign.
Then you can do the
0. Okay, now in the beginning of the notes, I kind of showed you guys the different ways. I love what you were saying that we're getting in trouble, right? We still have 2 different trig functions going on here. So let's see. When I have 2 different trig functions, I can't figure out what to do. What does it say we might have to do if we still have 2 different trig functions? Look for GCF. So let's go back and see. Okay. What do you guys see in both of these? What trig function? Cosine. Oh, you meant to say cos, okay. Right. We can't change these all to x's because we can't have sine and cosine both being an x. It can't work. So let's factor out a cosine because it's in both as a GCF. So we have a 3 plus, and here we have a 2 sine x equals 0. Now, just like when you guys factor out a regular GCF, and you guys did all your factoring, you took both parts and set it equal to 0. So you could have cos x equals 0, and then 3 plus 2 sine x equals 0. So we have to get the sine x alone, so we minus 3. And then we have to divide by 2 to get sine x by itself. Okay. So now when you guys do your second function key, one part's dealing with cosine, one part would be dealing with sine part. I feel like we're definitely going to need more time with this tomorrow. Yeah, okay. So let me ask you guys a question. Do you want homework to try tonight? I have a big review for tomorrow. Do you want to finish this and just get everything tomorrow?
Yeah.
Okay, that works for me. Okay. So this is good. We'll leave off with this part tomorrow for you guys.